Chapter 9: Analysis of Data. Statistical analysis, or statistics, is concerned with the development and application of methods and techniques for organizing and analyzing data. The basic purpose of statistical analysis is to summarize observations or data in such a manner that they provide answers to the hypothesis or search questions. Cautions in using statistics. First, the researcher should be aware of other concerns in using statistics. Second, the more controlled the research setting, the less is the need, in general, for certain statistical techniques. The anticipation of the analysis process determines what kinds of data will be needed. Lastly, the conceptual development of a research study should not, however, be dictated by the statistical techniques to follow. Cautions in using statistics. In order to organize and analyze the data collected for a study, it is necessary to place them in categories. First, the set of categories or values for any one variable should be derived from a single classificatory principle. Second, each set of categories should be exhaustive. Third, the categories within each set should be mutually exclusive. Last, but not least, the development of categories should be based in a sound knowledge of the subject matter and an anticipation of likely responses. Coding the data. Once the categories have been established and data assigned to them, it is necessary to convert the new data or responses to numerical codes so that they can be tabulated or tallied. Researchers traditionally have transcribed the observations or scores for each individual or case from the data collection instrument to coding or transfer sheets. Analyzing the data. Descriptive statistics. The 6 basic functions of descriptive statistics. 1. At the most basic level, the statistical analysis can indicate how many persons, objects, scores, or whatever achieved each value or fell into each category for every variable that was measured. 2. When it may be difficult to grasp the overall meaning of frequency distribution tables, pictorial representations can be used to portray a variety of characteristics. 3. Descriptive statistics are capable of characterizing what is typical in a group of cases. 4. Descriptive statistics can indicate how widely cases in a group vary. 5. Descriptive statistics can measure the relationship between or among different variables in the data. The 6th basic function that descriptive statistics can perform is to describe the difference between two or more groups of individuals. Analyzing the data. Inferential statistics. They are most commonly used to predict or estimate population parameters or characteristics based on random sample statistics, and to test hypotheses using tests of statistical significance, to determine if observed differences between groups or variables are real or merely due to chance. Parametric statistics. Most important, parametric statistics require the assumption of a normal population or distribution. When the data of a normal distribution are plotted on a graph, they should produce a curve that is symmetrical and unimodal. Its mean, median, and mode should all coincide, and there should be a constant area or proportion of cases between the mean and an ordinate which is a given distance from the mean in terms of standard deviations. Some examples of frequently used parametric tests include the following. 1. Z-test. 2. Student's t-test. 3. Difference of means. 4. Analysis of variance. 5. Post hoc tests. 6. Reliability coefficient. 7. Pearson's product moment correlation coefficient. 8. Regression. Next is non-parametric statistics. Non-parametric statistics are considered to be distribution-free. Non-parametric tests are usually, but not always, used with ordinal level data. 5 common examples are as follows. 1. Chi-square test. 2. Mann-Whitney U-test. 3. Wilcoxon-Sign test. 4. Spearman rank. 5. Kruskal-Wallis test. There are cautions in utilizing statistics. Perhaps the most important principle to keep in mind is that statistics, whether generated manually or by a computer, cannot substitute for early, sound conceptual development of their search design and statistical analysis. Even the most sophisticated, comprehensive computer statistical package is simply crunch numbers, with no real regard for the underlying theories and hypotheses. It is left to the researcher to determine which statistical techniques represent valid methods of analyzing data.